Hello dear students. Today in basic civil engineering subject we will discuss module number 4, introduction to surveying and leveling. In that topic is angular measurement, and in that topic subtopic is introduction about bearings. So as per G2 syllabus, in angular measurement topic, there is small topic of bearings. So today we will discuss about bearings. Before I start, I will introduce myself. I am Kuldeep Patel, Assistant Professor, Department of Civil Engineering, Government Engineering College, Bhuj. So bearing. So what is the definition of bearing? The bearing of a line is the horizontal angle which it makes with a reference line, means meridian. Fixed reference line, that is meridian. So bearing of line, it is nothing but it is the horizontal angle which it makes with a reference line. And depending upon the meridian, there are 4 types of bearing. Okay. So first one is true bearing. What is true bearing? The true bearing of a line is the horizontal angle between the true meridian and the survey line. The true bearing is measured from the true north in the clockwise direction. You can see the figure. This is the true north line, means our true meridian. And this is our true bearing line. Okay, so what is true bearing? It is the horizontal angle which it makes with the true north meridian or true meridian. Same way, this is our magnetic north line, that is magnetic meridian. And this is your magnetic bearing. So what is magnetic bearing? It is the horizontal angle it makes with the magnetic north or magnetic meridian. Okay. So you can see magnetic bearing. The magnetic bearing of a line is the horizontal angle which the line makes with the magnetic north. Same way, grid bearing. The grid bearing of a line is the again horizontal angle which the line makes with the grid meridian. Instead of here magnetic north, they use the grid meridian because we are discussing about the grid bearing. What is arbitrary bearing? The arbitrary bearing of a line is the horizontal angle which the line makes with the arbitrary meridian. So in all the cases you can see meridian are different. Because compass, as you know, it is always give the horizontal angle measurement. Okay, so you can see horizontal angle, but in the all the case meridians are different. So these are the 4 types of bearing. Okay, true bearing, magnetic bearing, grid bearing and arbitrary bearing. Now there are some other definition. In that first one is whole circle bearing. So what is that? The bearing of line measured from the north is called whole circle bearing. The angle is reckoned in the clockwise direction from 0 degree, coinciding with the north. So that is the whole circle bearing. And quadrant bearing or quadrantal bearing. The whole circle is divided into 4 quadrants, and the bearing is expressed with north or south as prefix and east or west as suffix. Quadrant bearing is also known as the reduced bearing. We will discuss in detail all the things. So this is the diagram of whole circle bearing system. You can see here 0 degree I have mentioned here, it is north direction. Then here 90 degree is mentioned in this direction, south 180 degree, west 270 degree. And this is your survey line OA, OB, OC and OD. OA line lies in the first quadrant, and this is the angle theta 1 which OA line makes with this north direction, which is theta 1. Same way, this is your OB line which makes angle theta 2 with respect to again north direction. This is your OC line, OC survey line which make angle theta 3. You can see this is theta 3, but again it makes angle with respect to north direction. And this is survey line OD which makes angle theta 4. You can see this is the theta 4 again respect to north direction. So all the survey line OA, OB, OC, OD which lies in all 4 different zone makes the angle theta 1, theta 2, theta 3 and theta 4 with respect to north direction. So this is nothing but your whole circle bearing. You can see the bearing of line measured with respect to magnetic meridian in clockwise direction is called magnetic bearing, and its value varies with between 0 to 360 degree. Whole circle bearing means 0 to 360 degree. The quadrants start from north and progress in a clockwise direction, as the first quadrant is 0 to 90 degree in clockwise direction, second 90 to 180 degree, third 180 to 270 degree, and up to 360 degree is the fourth one, as I already mentioned. According to figure, means the figure that I have shown you, this figure, A, B, C and D station fall in first, second, third and fourth quadrant respectively. The whole circle bearing of line is the angle of that line from the given north direction in clockwise direction. We have already seen this. For example, if you take WCO line OA, theta 1, these are arbitrary value. Theta 1 means 45 degree, lies between 0 to 90 degree. Line OB is equal to theta 2 is equal to 150 degree, which lies in the second quadrant. Line OC is equal to theta 3 is equal to 210 degree, which lies in the third quadrant. And line OD is equal to theta 4 is equal to 340 degree, which lies in the fourth quadrant. The prismatic compass measures the bearing of lines in the whole bearing system. As you know, there are 2 types of compass, prismatic compass and surveyor compass. So prismatic compass always gives the which type of reading? Whole circle bearing system type of reading. And surveyor compass always gives the which type of reading? Reduce bearing system type of reading or quadrilateral bearing system type of reading. Quadrilateral bearing system. In this system, the bearing of survey line are measured with respect to north line or south line, whichever is the nearest to the given survey line, and either in clockwise direction or in anti-clockwise direction. As shown in the figure, I will show you the figure. The first quadrant is called north quadrant in quadrilateral bearing system. Second quadrant is called southeast, third quadrant southwest, and fourth quadrant and northwest quadrant. You can see the figure. This is the figure. Your north direction is your east direction, south direction, west direction. Your whole quadrant is divided into 4 parts, 4 zone, 4 quadrant. Survey line OA in the first quadrant, which is northeast. Survey line OB in the second quadrant, which is southeast. You can see southeast. Survey line OC in the third quadrant, which is southwest, and survey line OD, which is in the fourth quadrant, which is northwest. So here we have divided our quadrant into 4 parts. That's why the name quadrilateral bearing system, because you have divided into 4 quadrant: OA, OB, OC, OD. First quadrant, second quadrant, third quadrant, fourth quadrant. Okay. The bearing of line which falls in the first and fourth quadrant are measured with respect to north line, as north is nearer than south line, and bearing of line fall in the second and third quadrants are measured from the south line, as south is the nearer line. And the surveyor compass measure the bearing of line in the quadrilateral system. As I told you, prismatic compass always follow the whole circle bearing system type, and the surveyor compass always follow the quadrilateral system type of quadrilateral system. Here you can see your survey line OA and survey line OD both are approaching towards the North Pole, you can see. And here survey line OB and survey line OC both are approaching toward the South Pole. Okay. Reduced bearing, which is also called RB, when the whole circle bearing of line is converted into quadral bearing, it is termed as the reduced bearing. As I already told you, it is also called reduced bearing. Quadral bearing is also called the reduced bearing because we are divided into 4 quadrants. We are reducing whole circle bearing. That's why name is reduced bearing. Thus, the reduced bearing is similar to the quadrantal bearing and its value lies between 0 to 90 degree, but the quadrant should be mentioned for proper designation. Okay, so we have up till now discussed what is bearing, what are the types of bearing, whole circle bearing and quadrantal bearing, which is also called reduced bearing. Now we will discuss about rule of conversion of WCB to RB. You know WCB means whole circle bearing and RB is reduced bearing. So here one table is given which is generally used when you have to calculate the RB. You can see WCB of any line means WCB is given and quadrant in which it lies. Suppose WCB of line lies 0 to 90 degree, which lie in the first quadrant. What is the rule of conversion? RB is equal to WCB. Quadrant is northeast. Same way, if WCB of line lies in 90 to 180 degree, quadrant is second. Rule of conversion, RB is equal to 180 minus WCB. Quadrant is southeast. Suppose WCB line lies in 180 to 270 degree, which lies in the third quadrant. What is the rule of conversion? RB is equal to WCB minus 180. Quadrant is southwest. Same way, suppose WCB of any line lies 270 to 360 degree, which is our fourth quadrant. Rule for conversion is RB is equal to 360 minus WCB. Quadrant is northwest. So this is a very simple table. I will give you the trick also how to remember this simple table. So no need to worry. So this table shows that when WCB is given to you and if you want to calculate RB, you can use this formula and you can easily calculate the RB. Same way, vice versa. Suppose RB is given to you, you can calculate WCB also. For that, what you have to do? For first case, what will be happen? RB is equal to WCB remains same. For the second case, if you want to calculate WCB, what will be? WCB is equal to 180 minus RB. So like way, you can calculate all the corresponding WCB if RB value is given to you. Okay. Now there are some other definition also. Forebearing and back bearing. Every line has two bearing, namely forebearing and back bearing. Forebearing is the bearing taken in the direction of surveying and back bearing is the bearing taken in the reverse direction. So forebearing means, as the name suggests, forward. Bearing taken in the forward direction of survey is called forebearing, and back bearing is the bearing taken in the reverse direction or backward direction of survey. It is called back bearing. I will show you the figure also so you can understand easily. The difference between the forebearing and back bearing should be 180 degree. This is very important. When you have two readings, forebearing, back bearing, always remember that difference of that two forebearing and back bearing always 180 degree. It means that one or both station of the line are subjected to local error. This topic we will discuss later on because right now we are focusing on bearing. That's why we will discuss this later on. Now I will explain forebearing and back bearing with the help of this figure. You can see your line AB is given to you. This is the north direction And this theta 1, this angle that we have measured, is called forebearing for line AB. And this theta 2 is called back bearing of line AB. You can see this is the direction of survey. Means this is the forward direction of survey. We are proceeding in this direction, and whatever angle we are making with respect to north direction theta 1 is called here forebearing of line AB, and theta 2 which we measure in the reverse direction of line AB is called back bearing of line AB. Same way you can see this figure. Here direction of survey is this. This is the forward direction of survey. And this is line AB. Here theta 1, that angle we are measuring with respect to north direction, is called forebearing for line BA. And theta 2, the angle which we are measuring with respect to north direction, is called back bearing, because we are measuring in the reverse direction of survey, backward direction of survey. So this is called, angle theta 2 is called back bearing. So this is a very simple example of forebearing and back bearing. Now there are some points that you have to remember when you deal with the forebearing and back bearing. First point is, in the WCB system, WCB means whole circle bearing system, the difference between the forebearing and back bearing, FB means forebearing, BB means back bearing. We are using short form of FB and BB. Difference between the forebearing and back bearing should be exactly 180 degree. And I already told you that whenever you have two readings, forebearing and back bearing of any line, the difference between the forebearing and back bearing should be exactly 180 degree. And this is the formula that you have to remember. Back bearing is equal to forebearing plus or minus 180 degree. Means suppose if you have forebearing reading, if you have a line, if you have forebearing reading, but you don't have back bearing, using this formula you can easily calculate the back bearing of that particular line. But here you can see FB is equal, back bearing is equal to forebearing plus or minus 180. So when we have to use plus sign is applied when forebearing is 180 degree. Value of forebearing is less than 180 degree. And minus sign is applied when forebearing is greater than 180 degree, means forebearing value is more than 180 degree. And this all you have to remember only for WCB system. In the quadrantal bearing system, in the reduced bearing system, forebearing and back bearing are numerically equal, but quadrant are just opposite. For example, if the forebearing of AB is given north 60 degree east, then what will be the back bearing of that? What is written here? Forebearing and back bearing are numerically equal, means value will be numerically equal, but quadrant are just opposite. North is, so what is the opposite quadrant? Southwest. So north 60 degree east, your forebearing is there. So what will be back bearing? South 60 degree west. Okay, so this is very simple. You can remember easily. Now here one example is given. Calculate the back bearing of line if forebearing are given. So you can see this line are given. AB line is given 265 degree, PQ line is given 160 degree, MN line is given 350 degree, and these all are the forebearing reading. And you have to calculate the back bearing of this all the lines. And you can see here this 265 degree, 160 degree, 350 degree. These all the readings are in which system? WCB system. So we have to remember the first formula. So how will you calculate? Back bearing of line AB is equal to forebearing of line AB minus 180 degree. You have to use this formula. Back bearing is equal to forebearing plus or minus 180 degree. But you can see here 4 bearing value is greater than 180 degree. What is the value? 265. So you have to use minus sign. So 4 bearing line is given 265 minus 180 is equal to 85. You just use your calculator and calculate this value. You will find your answer. It will come 85 degree. Same way, if you want to calculate back bearing of line MN, what will be the formula? Back bearing line MN is equal to 350 degree minus 180 degree. Again here 4 bearing value 350 degree is greater than 180 degree. FB greater than 180 degree. So 350 minus 180, you will get your answer 170 degree. Same way you can see back bearing of line 4 bearing of line PQ is given 160 degree, and if you want to calculate back bearing of line PQ, you can see here 4 bearing value is less than 180 degree. 4 bearing value is less than 180 degree. So what you have to do? You have to add 180. So back bearing of line PQ is equal to nothing but 4 bearing of line PQ plus 180 degree, because this value 4 bearing value 160 is less than 180 degree. So as per our formula we will add the 180. So 160 plus 180 is equal to 340 degree. Okay. So using this example you can easily understand, if 4 bearing is given to you and if you want to calculate back bearing in WCB system, how you can calculate. Okay. Now here some more example are there. This example is to find QB, means quadrilateral bearing, means reduced bearing from WCB. So you can see here I have drawn one figure, and north, east, south, west, these are the 4 quadrant, and you can see line PA is given, and I have given WCB value which is 35 degree 15 minute, which lies in the first quadrant, and from this WCB value I have to calculate quadrilateral bearing. Remember students, I have shown you the first table in which WCB is given to you and you have to calculate the RB, and I also told you that you can do that vice versa also. If RB is given to you, you can calculate WCB also. Okay. So both the examples are there. We can see one by one. So here this example is about to calculate QB from WCB. WCB is given to you. So how will you calculate? Solution is given to you. Line PA lies in the first quadrant. You can see it lies in the first quadrant, northeast quadrant. So what is the quadrilateral bearing of PA line? North 35 degree 15 degree east. How? Because we know RB is equal to WCB. So here in the first case your answer will be north 35 degree 15 minute east. Okay. You can see that particular table. I will show you that particular table. You can see this table. So here RB is equal to WCB. So WCB is given 35 degree 15 minutes. So what will be RB? RB will be same, but you have to mention the quadrant. Not 35 degree 15 minute east. Okay. So not 35 degree 15 minute east. Now take the second example. Here I have given the WCB value 130 degree. 130 degree. Okay. And you have to calculate again the QB. So here what is your answer? Line PB lies in the second quadrant. You can see in the second quadrant. So what is the QB quadrilateral bearing of PB line? It will be south 50 degree 0 minute east. How? You can see from here to here, north to south, what is the value? Total 180 degree, and already 130 is given to you, and you have to calculate this value from here to here. So what will you do? From 180 from here to here, you have to deduct 130 from up to this line. So from 180 minus 130, what will be the value? 50 value. And why south is because this line, as I already told you, PB line approaching towards the south pole. So whenever your line approaching towards the south pole, you have to write like this way: south 50 degree east, south 50 degree east. Okay, so from the figure itself you can easily calculate your answer. No need to remember the formula even. From the figure itself you can calculate your answer. Now come to the same table. You can see your WCB line lies in the second quadrant. What is the rule of conversion? RB is equal to 180 minus WCB. WC1 is given 130. Just put the value here, 130. 180 is already there. 180 minus 130, what is the value? 50 value. And your line, second quadrant line is approaching toward which pole? South pole. So always you have to write this way: south 50 degree east. Okay, you have to only see that which pole. So first and fourth quadrant always approaching towards the north pole. So northeast, northwest. And second and third quadrant survey line always approaching towards the south pole. So southeast, southwest. So based on these two pole, north pole and south pole, you have to write your angles. Okay. So you can see this is your second answer. Same way, third one. Here WCB is given 210 degree 15 minute, which lies in the third quadrant. So what is your answer? Line PC lies in the third quadrant. So what is the quadral bearing reading? PC is equal to south 30 degree 15 minute west. How? From here to here it is 210 degree 15 minute. Okay. So what is the rule of conversion? You can see, I will show you rule of conversion. If it is lies in the third quadrant, RB is equal to WCB minus 180. Okay, WCB is given to you, minus 180, you will get RB value. Again it is approaching toward the southwest. So your answer will be south 30 degree 15 minute west. You can see, you can also calculate using the figure also. This value from here to here is 180, from here to here, and from here to here it is 210 degree 15 minute, 210 degree 15 minute. So from 210 degree 15 minute, okay, if you deduct that value 180, what will you answer? 13 degree 15 minute. Okay, here this is one mistake is there. This angle will become here. I have make mistake here. It will become here. From 210 degree 15 minute, you deduct 180 from here to here. So your angle will be 30 degree 15 minute from here to here only. And it is approaching towards the south pole. So your answer will be south 13 degree 15 minute west. So dear student, just recheck this. This angle will be from here to here, not from here to here. It will be from here to here. Why? Because this is 210 degree 15 minute and this is from here to here, it is 180. So from 210 degree 15 minute, you just deduct 180. So what will be the answer? 30 degree 15 minute, same, but from here to here. And it is approaching toward the south pole. So answer is south 13 degree 15 minute west. Okay. Same way we will go for fourth example. So here you have to calculate QB from WCB and value is given 290 degree 45 minute. Okay. So here you can see 290 degree 45 minute is given, which lies in the fourth quadrant. So what will be the answer? Line PD lies in the fourth quadrant. Quadral bearing of this line PD will be north 69 degree 15 minute west. How? From north direction to here, what will the value? 360 degree. and 290 degree 45 minute, it is again from north direction to up to this stage. So from 360, this whole north to north here, if you deduct 290 degree 45 minute up to this, you will get this value. And what will be that value? 69 degree 15. 5 is here. 69 degree 15 minute. And this value, this line approaches toward the north pole. So we have to write this way: north 69 degree 15 minute west. Okay. So you can see based on the figure even you can calculate your answer. No need to remember that table also. From 360 you just deduct 290 degree 45 minute up to this point. So you will get this value, and that value is 69 degree 15 minute. But when you write your answer, you have to always see that your line approaches which pole. This line which lies in the fourth quadrant approaches toward the north pole. So always your answer will be north 69 degree 50 minute west. I have written here. So always remember your line in the first quadrant and third quadrant, first quadrant and fourth quadrant always approaching toward the north pole, and line in second quadrant and third quadrant always approaching toward the south pole. So accordingly you have to write your answer. Okay. Same way, here some more example, but here you have to calculate whole circle bearing from QB. So you can see how will you calculate. WCB is given, so you can easily calculate line PA minus north 15 degree east. Same example that we have seen right now. If you want to do, but here I will give you QB and you have to calculate WCB. You can calculate this formula. You can calculate using this formula. WCB is equal to PA minus, P is your line, PA minus north 15 degree east. Okay, same way WCB is equal to PB minus south 25 degree 45 minute east. WCB is equal to PC minus south 45 degree 30 minute west, and WCB is equal to PD minus north 10 degree west. So you can see here, this is our answer. Question is, if your line PA lies in the first quadrant north 15 degree east, and you have to calculate what is your WCB. What is our rule of conversion? RB is equal to WCB. So line PA is in the first quadrant, is WCB is 15 degree. You can see by this way you have to just mention your answer. You have to make this line, you have to show the north quadrant, north direction, and you have to show this first quadrant, your line PA and 15 degree. So in WCB and RB, in both the cases, your answer will be same, 15 degree. Now second question, line PB is given and your QB is south 25 degree 45 minute east, and you have to convert this value into WCB. Vice versa process, dear students. Up till now we have seen 4 examples in which you have to calculate RB and WCB is given. Here RB is given and you have to calculate WCB, and already we have seen one example of that, and this is the second example. So south 25 degree 45 minute east means it is in second quadrant. Southeast means this is your southeast quadrant, and you have to show 25 degree 45 minute means from where to where? From here to here, from south pole to this line. This value is given to you, south 25 degree 45 minute, and from north to this, what is the total? 180 degree. From north to south, what is the total answer? 180 degree. So from 180 degree, if you deduct this value, what is this value? 25 degree 45 minute, you will get from here to here. And what is that answer? 154 degree 15 minutes. So same thing I have done here. Line PB is in the second quadrant. His WCB is 180, means from here to here. You just deduct one from 180. This value 25 degree 45 minute. Your answer will be 154 degree 15 minute. Okay, clear? Take the third example. Here WCB line PC is given. Value is south 45 degree 30 minute west. So southwest is the third quadrant. You can see, just draw this way. Your line shows the north direction, shows your line PC. Okay, south 45 degree 30 minute west means from here to here, from south to this line, this value is 45 degree 30 minute waste. And from here to here, you know, north to south is 180. So from 180 north to south 180, you just add this 45 degree 30 minute. So what will be the answer? From here to here, 180 plus 45 degree 30 minute waste, you will answer is 225 degree 30 minute. So you can see, dear student, I am doing here calculation based on the figure only. I am not remembering my formula. And I also told you that no need to remember the formula. You just remember your figure. What is the figure is given? Based on that, you just calculate your answer. Take the fourth example. WCB is given, line PD is given, not 10 degree waste. You have to calculate, sorry, RB is given, not 10 degree waste. You have to calculate WCB. So it is in the fourth quadrant. You can see this is my fourth quadrant. I have shown my line also. PD line is there. Total, you know, from here to here, it is 360 degree. And this not 10 degree waste is given from here to here. You can see from here to see my cursor. This is your not 10 degree waste. So from 360, if you deduct this value, not 10 degree waste, what will be answer? 350 from here to here. So 360 minus 10 degree, your answer is 350 degree. So dear student, we have seen 4 examples in which WCB is given to you and you have to calculate RB, and next 4 example in which RB is given, QB is given, and you have to calculate whole circle bearing. And you can calculate this based on the figure also, and if you want to remember the previous table, you can do that also, no problem. Okay, same way I have mentioned some example of back bearing, fore bearing also. So you can see fore bearing of line PQ is given 38 degree 15 minute. Find the back bearing. Find the back bearing. So you can see here 38 degree 15 minute. You can see this value is less than 180 as per our formula in WCB. I told you BB is equal to fore bearing plus or minus 180. Here fore bearing is 38 degree 15 minute, which is less than 180 degree. So you have to add you have to add 180 also. So back bearing is equal to 38 degree 15 minute plus 180. Your answer will be 218 degree 15 minute. Clear? This 180 plus 38 degree 15 minute. So you will get your back bearing. Here you can say fore bearing line is 210 degree 15 minute. This value is greater than 180 degree. So here to find the back bearing of line, what you have to do? You have to deduct 180. So back bearing is equal to fore bearing. This is your fore bearing 210 degree 15 minute minus 180. So what is your answer? 30 degree 13 minute. We already solved this example, but I have some more examples, so I am showing you. Okay. Now dear student, we will solve some example also based on this fore bearing, back bearing. Okay. So before that, one more small topic, computation of angle. Observing the bearing of the line of a closed towers, it is possible to calculate the include angle. Include angle means the angle which occur inside the tower. This is the towers. You know what is the tower. There are two types of tower, open towers and closed tower. This is the example of closed towers. And you have to calculate the include angle. Include angle means which forms inside the towers. C, B, A, D. Okay. So at the station where two survey lines meet, two angles are formed. One is an external angle and another one is an internal angle. The interior angle or include angle is generally the smaller angle, means less than 180 degree. You can see the example of internal angle less than 180 degree, external angle greater than 180 degree at B. Okay. So as shown in the figure A, all angle ABCD are less than 180 degree, and as shown in figure B, you can see this is your figure B. The internal angle at station B is more than 180 degree. So while calculating the interior or include angle, it is strongly recommended that a rough sketch of the traverse must be drawn for the purpose of calculating the inter angles or bearing from include angle. A sketch always gives a better idea for calculation. Okay, means you have to draw a traverse, rough traverse. Once you draw the rough traverse, then you can proceed further. So for that, I will explain one example. I will explain you one example so you can easily understand when this type of example is given to you, how to do the calculation. Okay. So dear student, just see here, and if you are right now seeing my video, just take your pen and copy, and you just do the calculation with me. Okay. So what is the data? The following are the forebearing and backbearing of the lines of a closed traverse, and you can see I have given the data in which you have to make three columns. First column is about the line, second one is forebearing, and third one is backbearing. Line is given AB, BC, CD, D, EA. Okay. Forebearing is given for line AB 150 degree 50 minute, and backbearing of same line is given 330 degree 50 minute. Same way for line BC, forebearing is given 20 degree 30 minute, and backbearing is given 200 degree 30 minute. Same way for line CD, forebearing is given 295 degree 45 minute, and backbearing is given 115 degree 45 minute. For line D, forebearing is given 218 degree 0 minute, and backbearing for line D is 38 degree 0 minute. And for line EA, forebearing is given 120 degree 30 minute, backbearing is given 300 degree 30 minute. Calculate the interangle of the traverse. So this is your example. Now you have to solve this example. You have to calculate the include angle. So as I told you, you have to first of all draw the traverse. This is the basic one. This is the heart of the particular example. So how will you draw this traverse? This traverse you have to draw on a rough scale. No need to draw this traverse with a scale. You have to draw with a rough scale. Okay. So when you draw this traverse, you have to use all the forebearing readings or all the backbearing readings. Either one. Okay. So for drawing this traverse, I will use all the forebearing readings. So first of all, you have to take one point here. Okay. You have to draw this line. You have to show the north direction. Line A is there. What is your forebearing reading? 150 degree 15 minutes. So I will draw one line from A to B. 150 degree 15 minutes, it will be in a second quadrant. So this is your first quadrant, this is your second quadrant. So from here to here you have to draw this way one point, and then you have to draw this one line 150 degree 15. How much long this line you have to draw? That line you have to draw accordingly as per your judgment, because a value is not given between distance distance is not given from A to B. So we have to just roughly take this line. Okay, length of the line. So AB is 150 degree 15. You have to draw one line here. Then from B to C, again you have to draw one line, and you have to take the forebearing. So what will be the forebearing? 20 degree 30 minute. So you can see 20 degree 30 minute. You have to again draw this way. You have to make the quadrant 20 degree 30 minute in the first quadrant. So from first quadrant you have to draw one line from here to here. Okay, again length of the line is not mentioned, so you have to take roughly. Then from C to D, again you have to draw one line. For that I will take again forebearing 295 degree 45 minute. So you have to draw from here to here. 295 degree 45 minute means it will be in a fourth quadrant. So like this, from here to draw one line. From D to E, again you have to draw one traverse. What is the forebearing reading? 218 degree 0 minute. So 218 means it will be in a third quadrant. So again you have to draw this way line. You have to mention the quadrant, first quadrant, second quadrant, and third quadrant. From D to E, you have to draw this line, and you have to mention the angle 218 degree. And for EA, forebearing is given 120 degree 30 minute. So from E to A, 120 30 degree means it will be again in the second quadrant. So you have to mention the quadrant, and from here to here, you have to mention the angle, and then you have to draw one line. And this line should meet the, or must meet the A point. When it is meeting here, you can say your traverse is complete. Same procedure you can do with the help of backbearing also. Here I have taken all the forebearing reading. If you want to draw the traverse, you can draw the traverse with the help of backbearing also. Whatever is suitable to you. Okay. So by this way, first of all, you have to complete your traverse, and then you have to proceed further. Okay. So now we will proceed further. So now we will proceed further. So you have to calculate the angles. Okay. So don't remember right now exterior and interior. You just focus. So angle A is equal to back bearing of EA minus forebearing of AB. Okay. So what you have to do here, you can see these are angle A. And to calculate the angle A, we require two readings. One is forebearing and second one is back bearing. Okay, so here you can see I have taken back bearing of line EA. These are EA. This is the back bearing and forebearing of line AB. Okay, to calculate any angle, angle A, angle B, angle C, angle D, angle E, you require two reading. One is forebearing and another is back bearing. So here to calculate angle A, we require one reading is back bearing of line EA and another is forebearing of line AB. So I have taken that, and here back bearing of line EA is greater than forebearing of line AB. So I will just deduct 300 degree 30 minutes minus 150 degree 15 minutes. So you will get 150 degree 15 minutes. But here you can see whatever answer I am getting, answer is 150 degree 15 minute. You can see this is the 300 degree 30 minute. Okay, and this is 150 degree 15 minute. So here angle is formed outside the traverse. If I mention here both my forebearing and back bearing of line EA and forebearing of line AB. Okay, so how will you mention this 300 degree 30 minute? So this will be 300 degree 30 minute from here to here, and this will be 150 degree 15 minute from here to here. So this portion from here to here, you can see my cursor I will getting, and that is my 150 degree 15 minute. But here this angle is formed outside the traverse. That's why I have word use exterior angle A. And our aim is to calculate the interior angle. So what I have to do? You have to deduct your this value from 360 degree. So interior angle A is equal to 360 degree minus 150 degree 15 minute. You will get your answer 209 degree 45 minute. Okay. Same we can see angle B. Don't remember right now whether it is interior or exterior. You just remember your figure. So same way to calculate the angle B. Okay, angle B. Which two readings are required? One is forebearing, another is back bearing. But forebearing of line BC and back bearing of line BA. Okay, so you can see forebearing of line BC and back bearing of line AB. But here back bearing of line AB is greater than forebearing of BC. So I am just deducting my 330 degree 15 minute from 20 degree 30 minute. So I am getting 309 degree 45 minute. Now this angle is exterior interior. How will you find? So you have to go for your figure. So you can see here, if I mention here my forebearing, back bearing both, forebearing is already mentioned 20 degree 30 minute, and if I want to measure, I want to mention my back bearing of line AB, it will be 330 degrees, means from here to here. You can see my cursor, 330 degree 15 minute. So from 330 degree 15 minute, you can deduct 20 degree 30 minute. You will get this angle, and this angle is formed outside the traverse. You can see. Okay, traverse is this way, you can see, and your angle is forming here. So this angle is called exterior angle. You can see in previous case also your traverse line goes like this way, and your angle is formed here. So it is called exterior. So same way here, whatever answer you will get, 309 degree 45 minute is your exterior angle, and you have to calculate interior angle. So what you have to do? You have to deduct this 309 degree 45 minute from 360. So interior angle B is equal to 360 degree minus 309 degree 45 minute. You just take the difference, you will get answer 50 degree 15 minute. Same way to calculate angle C. Which two readings are required? You can see from the figure, forebearing of line CD and back bearing of line BC. So you can see here, forebearing of CD minus back bearing BC. Here forebearing is greater than back bearing. That's why I have deduct back bearing of BC from forebearing of CD. So there is no rule. Either you do deduct forebearing from back bearing or back bearing to forebearing. Whichever is greater than, you have to deduct from that. So here forebearing of CD is greater than from back bearing BC. So we have to just take the difference. So 295 degree 45 minute minus 200 degree 30 minute, you will get 95 degree 15 minute. But here you can say I have directly mentioned interior. Why? You can see the figure. So here 295 degree 45 minute from here to here. Okay, and another value is 200 degree 30 minute. So 200 degree 30 minute, if I want to mention here, it will be from here to here. So whatever answer you will get, that is you are getting inside the traverse. You can see. That's why it is called interangle. So angle D, as I told you, how to calculate? Forebearing of DE minus backbearing of CD. Forebearing is going 218 degree minus 115 degree 45 minute. 115 degree 45 minute. You will get your answer 102 degree 15 minute. Here again, you can see your traverse is formed inside the traverse. This is the 218 degree and minus 115 degree 45 minute from here to here up to this line, up to this survey line. So again you can see your angle is formed inside the traverse. So angle, interangle D. Same way to calculate angle E, two reading required, forebearing of line EA and backbearing of line D. Okay, forebearing line EA is 120 degree 30 minute minus backbearing of line D 38 degree. Your answer is 82 degree 30 minute. You can see here 120 degree 30 minute and 38 degree. So 120 degree 30 minute and 38 degree from here to here. Again your traverse is formed inside the traverse. So again it is interangle D. Okay. Once you calculate all the angles, you have to do this particular check. The sum of the interangles should be equal to 2n minus 4 into 90 degree, where n is number of side or number of angles. Here our number of side and number of angles are 4. So you have to just, 5. N is equal to 5 because 5 angles are there. 5 side is also. So you have to take n is equal to 5. Just put here n value. You will get 540. Once your check comes 540, your summation of all the calculated interangles must become 540. When this will be same, then your example is correct. So now we will check whether our all the angle summation are 540 or not. So angle A plus angle B plus angle C plus angle D plus angle E. You have to just put all the angles and you just check whether you are getting the 540 or not. You can see we are getting 540. So our answer is correct. Okay. So this is the first example that we have seen. How to draw the traverse and how to calculate the interangle. Same way we will see the second example, but here I will show you in a very brief way so you can solve easily. Okay, so you can see the following are the bearing observed in the traverse A, B, C, D, E, A with a compass. Calculate the interangles of the traverse and correct them if necessary. So you can see here again 3 columns are given, lines are given A, B, B, C, C, D, D, E, A. Forebearing values are given here and backbearing value are also given. Now same way you have to first of all draw the traverse. I will draw the traverse using all the forebearing readings. So you can see I have taken 150 reading, I have taken 1 point here and I have draw this line and I have draw one line from A to B by taking forebearing reading 150. Then I have drawn one line from B to C by taking the forebearing reading 230 degree 30 minute. Then I have drawn from C to D line by taking forebearing reading 306 degree 15 minute. Then I have drawn line from D to E by taking forebearing reading 298 degree 0 minute. And then I have drawn one more line E to A by taking forebearing reading 49 degree 30 minute. Okay, this is all the length of the line. It is as per your choice, means distance is not given, so you can take roughly. Okay, and just you take all the forebearing reading of all the lines and you just complete your traverse. Okay, you can say I have taken this all the forebearing readings. Okay, once you complete your traverse, you have to calculate the angle. So same way angle A is equal to backbearing of EA minus forebearing AB. Okay, so 229 degree 30 minute minus 150 degree 0 minute, so you will get 79 degree 30 minute. You can see the figure 229 degree and 150 degree. Okay, you will get angle inside the traverse. Then you have to calculate angle B, backbearing of AB minus forebearing of BC. Backbearing of AB is 330 degree 0 minute minus 230 degree 30 minutes. Answer is 99 degree 30 minute. You can see again, you can check this. So the 330 degree 30 minutes from here to here and 230 degree from here to here. So again you can see traverse is become inside the traverse. So angle B is interangle. Now angle C is equal to forebearing of CD minus backbearing of BC. Forebearing of CD is 306 degree 15 minute minus 48 degree 0 minute. Answer is 258 degree 15 minute. But here you can see 306 degree 15 minute minus 58. So you can see here traverse is from outside the traverse. So it is external angle 258 degree 15 minute. To get the include angle or internal angle C, you deduct this value from 360. So internal angle C is equal to 360 degree minus 258 degree 15 minute, 101 degree 45 minute. Same way you have to calculate angle D, 4 bearing of DE minus back bearing of CD, 298 degree minus 127 degree 45 minute. You will get one answer. But again, this will be your exterior one. Just check 298 degree. Okay. And what will be the next one? 127 degree 45 minute. So 298 minus 127 degree 45 from up to this line. So you will get this answer. Okay, this angle which is outside the traverse. So your angle D is exterior one. To get the interior, what you have to do? You have to deduct this 170 degree 15 from 360 degree. You will get 189 degree 45 minute. That is your again interior one. And angle E is back bearing of D minus 4 EA, 120 degree minus 49 degree 30 minute. You can see 120 degree 30 minute minus 49 degree 30 minute. So you will get your this answer. This is again forming inside the traverse, so it is your interior angle. So whether your angle is interior one or exterior one, that you can decide based on the figure only. Okay, you can't write directly this angle is interior or exterior. Okay, so as I mentioned you, as I told you, as I taught you, accordingly you just take the decision whether it is interior angle or exterior. Our aim is to calculate the interior angle, but whenever exterior angle will be there, you have to calculate first and then you have to convert it to interior. Once you get this, you have to check the summation. But here you can see this is the second type of example where you might not be get exact 540 or 360. Means if your n is equal to 5, your summation must become 540. If your n is equal to 4, your summation must become 360. But here, suppose if you are not getting 540, what you do? So this is the second type of example in which correction is required. So you can see I have put all the 5 angles, I have do the summation also, but I am not getting 540, I am getting 541. So what I have to do? There is some error. Instead of 540, you are getting 541, means total error is 1 degree positive. Because 2n minus 490, you getting your check 540, but you are not getting 540, you are getting 541. You are getting 1 degree more. So total correction is minus 1 degree. 541. If you want to do 540, what you to do? You to do minus 1 degree, means minus 60 minute. And there are 5 angles, so minus 60 upon 5, so minus 12 minute, means to come up to 540, you have to deduct minus 12 minute in all the angles. So you can see the table, angle A, B, C, D, calculate value that we already calculated, and this is the correction that I have done in the all the angle minus 12 minute, minus 12 minute, minus 12 minute. So total 60 minute. And once you do, you will get your corrected value. These all are your corrected value. So if you do the summation of this, you will get your answer 540. Okay, so this is the second type of example in which suppose error is there. So how will you do the correction? Okay, first one very simple, in which you have to just check as per your check you are getting your 540 answer or not. If suppose 4 angle is there, so 360 is there or not, you have to do. In second example, you are not getting 540, you are getting 541. Okay, because n is equal to 5 is there, so 540. If suppose n is equal to 4 is given, so you have to check 360. So here n is equal to 5, so you have to get 540, but you are getting 541, means error is there, so you have to correct. So how to do that correction, that I told you. Now this is the last example, because previous 2 example we have seen based on the WCB system. But suppose this your example is based on the quadrantal bearing system type of reading. So how will you do the calculation? So you can see the following are the bearings of closed traverse. Lines are given, fore bearing are given, back bearing are. You can see here readings are given in a quadrantal bearing system. North 45 degree 30 minute east, south 45 degree 30 minute west. Okay, BC is given south 60 degree 0 minute east, north 60 degree 0 minute west. CD is given south 10 degree 30 minute west. North back bearing is given north 10 degree 30 minute east. DA line DA for bearing is in north 75 degree 45 minute, and back bearing is given for line DA south 75 degree 45 minute east. Calculate the inter angle of the traverse. Okay, this is your example. So how will you do? Again, you have to draw the traverse. So you have to draw this way one line, then you have to draw line AB. Okay, by taking the fore bearing reading. So you can see my fore bearing reading for line AB is 45 degree 30 minute, which is in the first quadrant. So I have to draw this one line. Okay, 45 degree 30 minute. Then from line B to C again I have to draw one line. and that value I will take my 4 bearing readings. Okay, so for line BC, what is my 4 bearing reading? South 60 degree east. Okay, so you can see this is my south pole, this is my east. So south is 60 is given this way. So from here to here you have to draw one line, and then you have to mention the angle, and then you have to draw one line. What is the length of the line? It is up to your choice. Okay, because distance is not given. Then from C you have to draw again one line C to D, and you have to take the 4 bearing reading. Okay, so 4 bearing reading for line CD is given south 10 degree 30 minute west. So south is south pole, south to west is 10 by this way, and then you have to draw one line. Okay, and then DA is given north 75 degree 45 minutes. This is your 4 bearing reading. So you can see this is the north pole. So from north to this way, so 75 degree 45 minutes. Okay, so by this way you have to complete your traverse, and then you have to calculate the angle. So angle A is equal to 180 minus 4 bearing of AB plus back bearing D. Now you can see here in previous example what we have done, we have deducted 4 bearing from back bearing or back bearing to 4 bearing. Okay, that based on the figure. You have to always, whenever you do the calculation, you have to always remember your figure. So here to calculate the angle A, we have to remember our figure. So you can see our figure is, this is our angle A. Okay, this 45 degree 30 minutes. So you know, as per the mathematical rule, suppose if this is 45 degree 30 minutes, this angle will be also 45 degree 30 minutes. If suppose this is 60 degree, this will be also your 60 degree. Okay, if suppose this is 10 degree 30 minutes, this angle will be also 10 degree 30 minutes. Suppose 75 degree 45 minutes, so this angle will be also 75 degree 45 minutes. So this is 45 degree 30 minutes, this is 75 degree 45 minutes. Total from here to here is 180 degree. So from 180 degree, if you deduct this value and this value, you will get this answer. So same mention here, 180 minus 4 bearing of AB plus back bearing of DD. 180 minus 45 degree 30 minute plus 75 degree 45 minute is equal to 180 minus 1, you take the summation of this two, 121 degree 15 minute is equal to 58 degree 45 minute. Clear? So whenever, don't remember that we have to always deduct 4 bearing from back bearing, or from back bearing you have to deduct the 4 bearing from back bearing, or you have to deduct the back bearing from 4 bearing. No, we have to remember the figure, we have to see the figure, and accordingly we have to do the calculation. So same to calculate the angle B, you can come to the figure. So this angle we have to calculate, already 60 degree is given, and what will be this angle? This 45 degree 30 minutes. So as per the mathematical rule, this angle will be also 45 degree 30 minutes. So you have to just take the summation of these two angles, 60 degree plus 45 degree 30 minutes. So you can see back bearing of AB plus 4 bearing BC, 45 degree 30 minutes plus 60 degree is equal to 105 degree 30 minutes. Okay, same way angle C, this will be similar to angle A. Okay, so you can see, you know this angle. Okay, what will be this angle? If it is 60 degree, this angle will be also 60 degree as per the mathematical rules, and this total is 180 degree. So from 180 degree you just deduct this value and this value. Okay, so you can see 180 degree minus back bearing of BC plus 4 bearing of CD. 180 minus 60 degree plus 10 degree 30 minutes. So you will get 180 degree minus summation of this two, 70 degree 30 minutes, 109 degree 30 minutes. So this is same process that we have done in the angle A. And to calculate angle D, what will be the answer? This will be 75 degree 45 minutes. What will be this? As per the mathematical rules, suppose if this is 10 degree 30 minutes, this will be also 10 degree 30 minutes. So you have to do just summation of these two angles. So 10 degree back bearing of CD plus 4 bearing of DA is equal to 10 degree 30 minutes plus 75 degree 45 minutes. You do just summation of these two. So you will get 86 degree 15 minutes. Now again, what you have to do? We have to remember our check. Our check is 2n minus 4 into 90 degree. Here n is 4. Okay, because only 4 side and 4 angles are given. So when you put here n is equal to 4, you will get yours check is 360 degree. And you have to also check whether your answer is also 360 or not. So if you do summation of all the angle, you will get 360. So here your check and your answer is matching. So this is your final answer. Okay. So now I am completing this my video. Okay. If you have any query, you can contact on my email ID. Please write my email ID kbpatel 5 times 9 99999. KB Patel, KB Patel, PATEL 99999 @gmail.com. Okay, thank you.